All right, we're going to wrap up chapter 6. 6.8 here is on doing a little graphing. We're graphing square roots and graphing cube roots. So we're going to investigate what they look like. In order to do that, we're going to start off with just the graph of the y equals square root x graph. And when we look at that, you might want to think back, what's the domain of that? The domain is x is greater than or equal to 0, or we could say all reals greater than or equal to 0, because you can't square root a negative. And consequently, the range is y is greater than or equal to 0 because you can't get a negative. We plug in numbers for x, there's no way to get a negative. You can get 0, but you can't get a negative. You can get higher than a negative, but no negative. What am I saying here? Well, let's think of some numbers we can plug in. If we plug in x is 0, that's the smallest thing we can plug in. Square root of 0 is 0. That tells me that 0, 0 is going to be on my graph. Plug in x is 1. Square root of 1 is 1. 1, 1's on my graph. You can plug in 2 and do square root of 2, but that's not much fun. So we're actually going to plug in nice, easy numbers to work with there. We've used 0, we used 1. The next easy one would be 4, because the square root of 4 is 2. And one more would be 9. The square root of 9 is 3. So I got 4, 2, 5, 6, 7, 8, 9, 3. The square root function basically is half a parabola that's facing to the right. You see the square root here? That's just half a parabola facing to the right. If you wanted to get the other half, you would simply do y equals negative square root x. That would give us the other half, because all our numbers on the right, well, except for 0, would turn into negatives. And think about transformationally how that works there. If you have a negative in front, that reflects over the x-axis, so that would put me here, and put me at the same starting spot. Put me here, and 3 down here. So you see that would give me the other half of my parabola. That's why when you have the function y equals x squared, which is a parabola like that, and I say, is the inverse a function? No, it's not a function, because not only does this fail the horizontal line test, but if you take the time to actually graph it, you switch x and y, do the square root, whenever you square root, you do plus and minus. Take the time to graph it, you see that a vertical line doesn't work. Since it's not a function, you can't put it in a graphing calculator per se, unless you trick your calculator and put in y equals square root x into like y1 and do y2 equals negative square root x. And that would be how you can trick your calculator into graphing that parabola. Okay, well, what do you do if you've got some transformations? If you have some transformations, we're going to go ahead and just start with that same parent function, y equals square root x. We're going to use the same numbers, 0, 1, 4, 9, 0, 1, 2, 3. We want you to go ahead and graph that parent function every time. Just like that. But then we're going to make our adjustments by looking at the numbers up here and thinking transformationally. We've got a 2 up here, we got a 5, and we got this minus 1. Spent a lot of time first semester talking about what the transformations take place because of those numbers, so we'll review. The plus 5 on the inside tells me to actually go left 5, and that is the only one that affects the x. So what I'm going to do is I'm going to write down that the x needs to go left 5, and to do that I subtract 5. 0 minus 5 is negative 5, 1 minus 5 is negative 4, 4 minus 5 is negative 1, and 9 minus 5 is 4. Now the 2 and the 1 up there, the minus 1, they affect the y, because the 2, I don't remember, is a vertical stretch. The minus 1 at the end just tells you to go 1 down. It's important to follow the order of operations in that you need to do that vertical stretch first. So I've got a vertical stretch of 2, and that just tells me to multiply my y's by 2. So my new y's are 0, 2, 2 times 2 is 4, 3 times 2 is 6. Finally, you've got that minus 1, and I already mentioned that that just tells you to go down 1. So that's a minus 1 on the y's. 0 minus 1 is negative 1, 2 minus 1 is 1, 4 minus 1 is 3, 6 minus 1 is 5. These are my new xy's. These are the xy's that I want to graph for my answer. So my answer, I'll do that in purple, is at -5, -1, -4, +1, -1, +3, and 4, 5 right here. Common mistake is people think, oh, this is going to all of a sudden go down here to the left, and that's bad. Make sure that you don't go any further left or any further lower than this starting point, which is right here. That starting point represents our domain and range. Domain is your x's. This graph, the purple graph, doesn't go any further to the left than -5. -5 is the smallest thing I can plug in up here. Because if I plug in anything smaller than -5, I'm trying to square root a negative. That's bad. So domain is all reals greater than or equal to -5. Or I could say x greater than or equal to -5. Range, that's your y's. Those are the answers you can get. I can't get any lower than this point right here, and how low that thing goes is -1. So the range is all reals greater than or equal to -1. This one goes upwards. You might end up with a range that's less than or equal to, and that's if you had a negative in front, because that does that reflection. So if you end up with something that curves it down because you had a negative in front, then you're going to have range is less than or equal to -1. That's how the graphing of square root works. What about third root? Well, third root's a little nicer because you can third root anything. I can third root a negative, I can third root a positive, I can third root 0, and subsequently I can get any answer. When I third root a negative, I get a negative. Third root a positive, I get a positive. So the domain on range on all of these is going to be all reals all the time. If the only thing you've got going is the third root, domain range, all reals all the time. We're going to start with our parent function. We can plug in anything, so I want to get a good cross-section of numbers to plug in, meaning I want to get some negatives involved, and I'm going to plug in numbers that are easy to work with. Here are the numbers you should plug in when doing a third root. You can third root -8, -1, 0, 1, and 8. I want you using those 5 numbers. Third root of -8 is -2. Third root of -1 is -1. You get 0, 1, 2. We're going to graph our parent function over here. If I only did 3 points, -1, 0, and 1, notice they look like they're in a line, so that's not a good representation of the graph. When you plug in 8, you can say, oh, wait, it's not a line. It actually ends up curving there. And I got -8, 2, 4, 6, -8, -2. Makes kind of a S that's been compressed vertically compressed or horizontally stretched. So that's the parent function. We're going to draw that every time when we're doing the next type of problem here, which has the transformation. So we're going to go ahead and start with the parent function. Now I've got some transformations to apply. So I start with this. I've got these 3 here. They're easy to find. The 8, I got to do some counting. 2, 4, 6, 8, 2. 2, 4, 6, 8, 2. There's my parent function. What happens to my final graph? Well, I'm going to do the same thing I did above here. I've got a -2 in front. I've got a -3. And then finally, I've got this +1. The -3, that's kind of like it's in parentheses. We can deal with that first. That's the only one that affects the x. So I'm going to go ahead and say that that is 3 right. And I'm going to add 3 to all my x's. So -8 plus 3 is -5. -1 plus 3 is 2. 3, 4, 11. Those are my final x's because that's the only thing that affects the x. Next, I have to deal with the -2 before the +1 because of the order of operations. And the negative 2 is actually two things, but I'll let you go ahead and apply them at the same time. You're going to multiply by negative 2, but if you're going to describe transformationally what's going on there, you would say that it's a reflect over the x because of the negative, and it's also a vertical stretch of 2. You tell me both of those. One of them just switched the sign, the other one's multiplied by 2, so we'll do both at the same time. Negative 2 times negative 2 is 4, 2, 0, negative 2, negative 4. And then finally, the plus 1, that tells us that we're going to go 1 up. So we go 4 plus 1 is 5, 3, 1, negative 1, negative 3. Here's my new coordinates. 4 goes with negative 1, 11 goes with negative 3. And then I'll go ahead and use the purple, I guess, on this. So I got negative 5, 5, 2, 4, 5, 5, 2, 3, 3, 1, 4, negative 1. Should still look like they're in a line. I think let's see, 3, 1, 4, negative 1. Oh, I guess that's right. Okay, and 11, negative 3, right there. Okay. Still the same shape, but it's been flipped over. That was a negative, and then it's a little bit taller because of that vertical stretch. And then the 3 right and 1 up. Moved your center point here. There's your center point right there. That's at 3, 1. It used to be at 0, 0. Domain range, all reals. For both of them, you never stop going left, right. You never stop going up, down. So you got all reals for the domain and all reals for the range. Okay, we're not going to graph all these here. I'm just going to go through what we're looking for. This one, you might look at and say, oh, we go 54 to the right. But that's not true because of this 27 right here. If it was just x minus 54, you would go 54 right. So when you have a number in front, what you need to do is factor that number out. So I'm going to factor out a 27 from this expression right here. 54 divided by 27 is 2. So the inside turns into third root of 27 times the quantity x minus 2. And then you got this other minus 2 at the end. Well, I could split this third root up into the third root of 27 times the third root of x minus 2, because it's okay to multiply 2 third roots, put them together, so it should be okay to pull them apart. And what I end up with then is 3 times the third root of x minus 2 minus 2. So that's a simplified version. Now, if we were going to take the time to graph it all, you'd say, oh, it's the third root. So you go and start with the parent function that's got negative 8, negative 1, 0, 1, 8. And this tells me that, wait, it looked like 54, right? But it's actually 2 to the right. So I got to add 2 over here. So you have negative 6, and 1, and 2, and 3, and 10. And then this 3 out front would tell me to multiply the y's by 3. So I'd have negative 6, negative 3, 0, 3, 6. And finally, the minus 2 at the end here would tell me to subtract 2 from the y's. So you got negative 8, negative 5, negative 2, 1, and 4. And those are the resulting x, y's that you need to graph. Okay. So if there's a number in front of the x, you got to divide it out and then put it out front there. On the test, they'll all be nice where you can either third root them or square root them real easily. So our last one is a square root. Same deal, you got a 25 in front. You got to have a plain old x, so we're going to factor out the 25 out of the inside, and that turns into 25 times the quantity x plus 3. Then we can go ahead and rewrite it as negative square root of 25 times the square root of x plus 3. Plus 4, and of course the square root of 25 is 5, and this would be what the simplified version of what you'd want to use to graph it. So you've you've got that, you actually don't go 75 left like you might have thought. You actually go 3 left. You've got a negative in front, so it's a reflector over the x. You've got a 5 in front, so it's a vertical stretch of 5. And then the 4 at the end tells you to go +4. Remember, when you graph these, you're supposed to use 0, 1, 4, 9. So remember, those are crucial points to be using. And then we'd apply those transformations to our graph here. Let's apply it to 0, 0 because it's important to know what happens to 0, 0 so we can get the main range. So if I apply it to 0, 0, I'm supposed to go 3 left, 3, -3. And there's that -5 in front, so I'm going to multiply by -5. That still puts me at 0. That doesn't change the 0. And then finally, I'm going to add 4. That adds to the y. So that 0, 0 point, this is what my graph normally would look like here. Well, the 0, 0 gets moved to -3, 4. Like that. So that actually changes my domain. My domain range start being x is greater than or equal to 0 and y is greater than or equal to 0. But the domain is, either use x or all reals. Actually now it's greater than or equal to -3. Because you can't go any further left than -3. And the range is all reals greater than or equal to 4 because you can't go any lower than -4. So there's our lesson on square root, third root graphing. Thanks for watching. Have a great day.